which is division of polynomials. We start off by talking about dividing by a monomial. So dividing by a monomial is really nice. If you think about like adding or subtracting fractions, right? Right. If you recall something like 1/4 plus 2/4, that's really 1 plus 2/4, right? Right. And you can add that. But it's kind of like this is the monomial, right? The top is your polynomial. Now you got two terms. Right? So if I asked you, write as a sum of fractions 3 plus 5/7. I want you to show that to me like you are adding fractions. What would it look like? I don't want the answer. I want you to show it to me like you are adding fractions. What would it look like?
You want to send it to you?
No, go ahead and just, you can just say it out loud.
So are you saying like 3/7 plus 5/7?
Exactly, right? That's all I'm saying, right? This would be just 3/7 plus 5/7, right? You just wrote that problem like a sum of fractions. And this is what you do when you divide a polynomial by a monomial. So when dividing a polynomial by a monomial, just rewrite as a sum of fractions and simplify each fraction. Right? It's really nice, right? Divide or rewrite it as a sum of fractions. Rewrite it as a sum of fractions. Then simplify each one. So let's take a look at an example here.
Hey, Mr. Santoya, could you go back real quick?
Yes, sir. There you go. Just let me know when you're done, please.
Okay.
All right. We have 12x to the power of 3 plus 8x squared plus x plus 4. We're dividing that entire thing, that entire polynomial by this monomial of 4x. right? So we have a polynomial divided by a monomial. And as I mentioned in these notes, let's just rewrite it as a sum of fractions. So how many fractions are we going to be having here?
4.
4.
4.
Very good. Yeah, and it's just 12x to the third over 4x, right? Plus 8x squared over 4x. Plus x over 4x. Plus 4 over 4x, right? We show each one of those terms over 4x. And now from there, all you got to do is simplify each one of those fractions individually, right? Individually, right? What you'll be doing is, work with the numbers, divide the numbers, right? Divide the numbers, right? Then look at those letters, look at the letters, look at the letters, right? What are we left with? The first one is going to be what? Simplified.
3x squared.
Good job. 3x squared. The next one, 8 divided by 4.
2.
And then you have 2 x's on the top, 1 x on the bottom. You're left with how many x's?
1.
Very good. The next example, you're going to be left with the fraction, y'all. Because the 4's in the bottom, it's got to stay in the bottom. All you can do is really just cancel out those x's, right? So you still have to be left with 4 in the bottom. Nothing's on the top, which means what's really left on the top then?
1.
Good job. 1. That one's a little tricky. Be very careful there, right? And the bottom, same idea, right? You cancel out those, right? The x is in the bottom. It's got to stay in the bottom, leaving you with a 1 on the top. Does that make sense, y'all, with those last two specifically?
Yes.
All right. We can't do anything else, right? So that is our answer for this example there. We divided that polynomial by a monomial. Any questions with that example? Next example. You got 8x to the power of 4 times y to the power of 5 minus 3x to the power of 3 times y to the power of 4 plus 5x to the power of 2 y to the power of 3. That entire thing is over x to the power of 2 and y to the power of 3. Once again, it's a polynomial divided by a monomial, right? So how many fractions this time?
3.
Very good, right? 8x4 y to the 5th over x squared y to the 3rd minus 3x to the 3rd y to the 4th over x squared y to the 3rd plus 5x squared y to the 3rd over x to the power of 2 y to the power of 3. Looks like we don't have any numbers in the denominator, so we're just really working with these letters and their exponents. Do we see any cancellation? X squared, y to the 3rd at the end, y to the 3rd. Those are identical. Okay. So what are we left with here? The first term will be 8 what?
8x squared.
8x squared y to the power of what?
2.
Good job. Minus 3 what?
X, Y,
Good job. Plus, we cancel.
5.
There you go. Very good. All right, so some nice examples there. Any questions with these two examples, y'all? Really quickly, I want you to understand that this is only possible when the bottom is a monomial. When the bottom is a monomial. That's the only time you can do this. If the bottom is not a monomial, we have to do some different things. And that's what we're going to talk about next year. Anyone need another minute? Copy this down. All right. Let's take a look here. So, dividing by a non-monomial term or polynomial. So if you're dividing by a non-monomial polynomial, you have two options. There's two methods. One method is long division. Second method is synthetic division. Right, but synthetic division can only be applied if the divisor, right, can only be applied if the divisor, if what you're dividing by is linear and the slope is 1 or the leading coefficient is 1. And I'll elaborate on that, okay? As we take a look at an example. Y'all, you should expect one long division problem on the test. You should expect one long division problem on the test. Right? So let's take a look at an example here. Divide x to the second plus 5x plus 8 over x plus 3. I need you to notice not a monomial. So we cannot do what we just did in the previous two examples. Which means this method or that method. Right? This is not a monomial. Right? So let's take a look at it by long division. Okay? Long division. We put the divisor on the outside. So x plus 3 goes on the outside. In the inside, we put the numerator, x squared plus 5x plus 8. We're going to divide x squared by x. What is x squared divided by x? What does that give us?
X.
X. Good job. We put that on the top. And now with that x, we multiply it to x plus 3. Whatever we get, we put it right there. Let's note also the steps. This was first, right? This was second. This was third. What do we get? We multiply those? Should be x squared plus 3x. Now we're going to subtract that. All right, that's what our fourth step looks like. And then our fifth step is whatever we're left with. What are we left with here? X squared minus x squared is gone. What's 5 minus 3?
2x.
2x. You bring down to positive 8. That's our sixth step there. Showing these as steps to help you out because students really struggle with this, right? So I really want to try to break this down for you. Then we do 2x. We're going to divide it by x. Notice that we're always dividing by that. Right? We're always dividing by that. What do we get? What's 2x divided by x?
2.
Very good. 2, it's a positive 2, so that goes up here. It's looking like our eighth step there. And then that 2, we're going to multiply it to x plus 3 again. It goes right in there. And what do we get when we do that?
2.
Looks like x plus
Where you at?
right over here. I'm distributing 2.
2x plus 6.
Good, 2x plus 6. So now right here we can subtract that.
Mhm.
And 2x minus 2x, that's gone. And what about 8 minus 6?
2.
Good. Right, so our answer here, right, we're done. We have nothing else that we can do. Right, the solution, the answer is x plus 2, right? And we got a remainder of 2. All right, our answer is x plus 2.